Hello everyone, welcome to the next lecture on the calculus. Today I will explain you how you can find the higher order partial derivative. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of the Mathematics 1 calculus. In this playlist you can see the various lectures related to the limits, partial derivative, implicit function, chain rule, all are available in this playlist. You can subscribe my YouTube channel so that when I upload in my next video you will get the notification. Now, dear students, what we have discussed in our last lecture, we have learned how you can find the partial derivative with respect to x and y. For more detail, you can watch this lecture available at my YouTube channel. Now, in this lecture, we will see how you can find the second order as well as the higher order partial derivative. First of all, if you have the function of the two variables, then the corresponding partial derivatives with respect to x and with respect to y are also the function of the two variables. On the other hand, if you have the functions of the three variables, f is a function of the three variables, then the partial derivative of f with respect to x, with respect to y, and with respect to z are also the functions of the three variables. Or in general, if you have the function of the n variables, then the partial derivative is itself the function of the n variables. Now, once we are talking about a function which is a continuously differentiable, make sure once the function is my continuously differentiable, then you can define the second order partial derivative, which I have discretized into the two categories. First one is a direct second order, and the second one is my crossed partial derivative. The direct will be fall under all those variables which have used the same variable like x into x, y into y. What does the meaning of this is? That means you have to find the partial derivative of the f with respect to x square. That means twice of the x. That means you have to find the partial derivative of x two times with respect to the x. In case of the single variable, if you have the function of the x, then this quantity will represent you as the second derivative. Similarly, del square f upon del y square define the partial derivative twice with respect to y. On the other hand, the cross partial derivative defines as firstly, you have to differentiate f with respect to y, and then you have to differentiate this with respect to x. Make sure, student, if I write this quantity as my del x del y, fine, then firstly you have to differentiate this function with respect to y and then with respect to x, fine. So that means the derivative of f firstly with respect to y and then with respect to the x. Similarly for this case, this is called as the cross partial derivative. It is also called as the mixed derivatives. Now, what are the various notations? If you consider the x as a 2 times, I also denoted the same quantity as a x into x. This is the y square, I also call as the y into y. This number firstly with respect to x and then y, so I call as a y into x. And the same thing, this number is my x into y. I also denoted this quantity, I can return this value is firstly with respect to x, so it's a y, and then del f upon del x. Same I can write for this expression. Another way, if I write this value as del f upon del x square into del y, this is similar I can call as, because x square I call as a xx into y, and similarly you can write as a x y y. Now, once you have find the partial derivative with respect to y and x, if both are my continuous, then you can say fxy and fyx are my same, and this result is called as the Young theorem, fine. However, always remember that it is not always true they are equal. Once the functions are my not continuous, then these are not equal. How you can compute them? That's very simple. As we discussed in our partial derivative lecture, we have find the partial derivative this manner. Now, how you can find this second order partial derivative? Remember, this I can write like of this manner, fine. What is this del f upon del x? Del f upon del x I can written like the f of x Now it is similar of this value. Fine. The only thing is I can replace the value of the f to my fx. That means I can replace here is instead of the f to my fx. Similarly, if you want to calculate the fyy, what does it means? Del f upon del of this value. So again, what does it means? I can write this value is my fy. So that means your target is to find the partial derivative with respect to y. Instead of this f, I can consider as a f of y. Finally, if you want to calculate, this is my say del x del y. How you can write that? This is del into f of y. I can apply this definition again. Instead of the f, I can replace to be the f of y. Always remember student, this definition you can apply whenever you have the function is of this cases category, like x into y is not equal to, for example, 0 comma 0 and something. On the other hand, if you have the function which is say polynomial or trigonometric functions, any of things, then you can easily differentiate this either by using the limits definition, or you can easily do that. For example, now clearly say this is my cases example. So I can find this fx 0 comma y by the definition of the limit. Limit h approaches 0. We need to find the partial derivative with respect to the x. That means I can keep y is my constant. So what is the definition of this? I can keep y is my constant. So that's a 0 comma y, and this is y is my constant. I can vary that this is my 0 plus h. Now 0 plus h is my h. I can substitute this limit. What is the value of the h comma y? H comma y is my non-zero, so this is the expression. So that is my h into y, h square minus y square divided by h square plus y square minus, what is the value of the 0 comma y? X, in this case both are 0, but in this case they are not 0. I can substitute expression in this case, but you can see this is the value of the x into y. When I take x is my 0, y is my y, so this value is my 0. Fine. Now clearly say after this case you can see y, h and h will be cancelled out. Expression here. If you substitute y is my 0, h is my 0, it is my minus y square over y square. Answer is minus 1. Similarly, you can apply the limit definitions for the case of the this. Again, you can substitute the value of the f of x comma h, this value, x comma y. Y is my 0. Again, y is my 0. So this expression is again 0. Again, h will be cancelled out. And if you substitute h is my 0, your answer is x. Now, your target is to check whether f of xy and f of yx are equal or not. How you can write this value? This is my del upon del x of fy. Fine. So I can apply again the limit definitions with respect to x on the value of the f of y. Now substitute this limit. What is that limit of the h0? F of y. This is the value of the fy we have obtained. H comma 0. So that means this number is h. 0 comma 0 is 0 over h. Answer is 1. Similarly, I can write this expression is del upon del y of fx. I can apply the limit definitions on the changing y, but the function is my fx. Fine, keeping x is my fixed number. Now if you substitute the limits, what is the value of the fx? Is a minus of y. So this y is my h minus 0 over h. Answer is minus 1. Now clearly say both the limits values are not same. Therefore, fyx and fyxy at the particular point 0 comma 0 is not true. Okay, look at this another case. Now clearly say this function is my continuous. Fine. Once it's a continuous, then there is no need to apply the limit definition. You can directly find the value of the fx. What is the meaning of the fx is y keeping constant. What is the derivative of this? 3x square. Sorry, with respect to x. So this is my 6xy minus 2y. This is 0. Fine. What is the partial derivative with respect to y? Keeping x as my constant. 3x square minus 2x plus 10 of 1. Then your target is to find the fxy. What does it mean? Firstly, differentiate this with respect to y that we have already obtained. Now you have to differentiate this function with respect to x, 6x minus 2. And similarly for the f of yx, firstly differentiate this function with respect to x. I have already obtained. Now you can answer this with respect to y. So 6x minus 2 both have the same. So yes, this relation holds. Similarly for this case, firstly you have to find the partial derivative with respect to x with respect to y. If you differentiate this with respect to x, 7x raised to power 6 ln of y plus cos x into y into y. If you differentiate this with respect to y, over y plus x cos of xy. Fine. Now f of x into y, this is the f of y. You can differentiate this function with respect to the x, 7 x raised to power 6 over y. Now it's a product rule, so it's a 1 into cos xy minus x sine of xy into y, so it's a xy. Similarly, you can find the partial derivative of fyx. This is the fx. You can differentiate this with respect to y. So it is my 7x power 6 over y. You can apply the product rule and you can see both the results are same. Look at this another example. I hope you can like and comment on this video as well. Your target is to find the value of the fxx, fxy and so on. Firstly, find the value of the fx, fy. Because this is not the cases of this manner, you can find the partial derivative directly. So keeping y square is my constant. So this is e raised to power x into y. So that is my y cube plus 1 over y. Now with respect to y, I have to apply the product rule. So first function into x. And the second part is e raised to power x into y of 2y. What is the partial derivative of x over y is minus x over y square. Then f of x. Find the partial derivative of this with respect to x again. So it's a e raised to power xy into y. So it's a y4, 1 over y is my 0. Fine. Find the yy. Again, you can apply the product rule. I can take an x is my outside. It is e raised to power x into y into with respect to y. So that's the x fine of y square plus e raised to power xy into 2y. Again, you can apply the product rule plus twice 1 into e raised to power xy plus xy into e raised to power xy plus 2x over y cube. Fine. Now you can take e raised to power xy as a common and you can simplify this. Now your target is to find the value of fxy. Firstly, you have differentiate this with respect to y. Now you can differentiate this function with respect to the x. So in this case, y square is my constant. So e raised to power xy into y plus e raised to power xy into 1. In this case, 2y is my constant. So e raised to power xy into y, that's a y square. And this part is my minus 1 over y square. You can take e raised to power xy as a common, you will get this expression. Similarly, you can compute e f of yx by on. Now, is there any function exist for which f of x and f of y are this value? So let's say assume that this function, such kind of the function exists. Now, fx and fy both are my continuous functions. Fine. So that means fxy and fyx both are my exist. fine, and they are continuous also. And once fxy and fyx is a continuous everywhere, what does it means? That means both are my same. Fine. Now you can find the value of this. What is the f of xy? You can differentiate this fy with respect to the x, e raised to power x sine y. Differentiate f of x with respect to the y. So it's a minus sine y. Now clearly say that's the meaning of twice e raised to power x sine y is my 0. That implies sine y is equal to 0. Why? Because e raised to power x can never be 0. Now since this result is true for all those values of the y, is it true? This is false. Why? Because it's a for all y. If you consider y is my pi over 3, then clearly say sine of y is my non-zero. Hence, such kind of the function does not exist. Now, the next category is how you can find the chain rule, how you can find the partial derivative with respect to the chain rule. But before you can watch this here, I recommended you can watch about my previous lecture of the chain rule to understand it deeply. Now, look at that. Your target is to find the del square. So firstly, you have to find this number. Now clearly say f, or you can call as a z, which are dependent on the u and v. U and v are also dependent upon the x and y. That means we can apply the chain rule. Fine. Now let's start with this category. Clearly say f is dependent, y is my independent. F is dependent on the u, f is dependent on the v. Now you can complete this matrix. What is the partial derivative of u with respect to the y? X square. V with respect to y, 2. F with respect to u, del f upon del u. F with respect to v is del f upon del v. Now what is the answer of this? That is a x square into del f upon del u plus del f upon del into 2. Fine. This is the first partial derivative of this function. Now your target is to find this second case. Fine. How you can write that? This is del upon del y into fy. Now again I can apply the chain rule. This is fy is my dependent variable, y is my dependent. Fy, this is the expression of the fy. Fy is dependent upon the x because of this number. Fx is dependent on the u and it is on the v. So I can say u, this is my, I call as the x, and this is my v, and u, this value and here. Now can you find the value of del u by del x or del u by del y? Del u by del y is my x square. This number is my del x upon del y, which is 0 because x and y are my independent. Del u by del x is my, del u upon del y is my 2. Now your target is to find this number. What is the meaning? What is the value of this? This is del upon del u of fy. Fine. This is my fy. Now can you differentiate this with respect to y, with respect to u? So x square is my constant. So this is my del square f upon del u square plus, because f is dependent on the u, so I can say this is my del square f over del u del v. Fine. Similarly, this line implies you have to find the differentiate with respect to the x. So this number is my 2x del f upon del u, because this expression f is independent of the u, so this is expression here. Similarly, can you differentiate this expression with respect to the v? So x square is my constant, so it is a del square over del v into del u plus twice del square f upon del v square. Fine. Now once you have completed this matrix, how you can find this expression? That is x square into this number, 0 into this is my 0, twice of this expression. Now You can open this bracket, and we all knows f of uv is f of vu because it is my continuously differentiable function, and you can get this because it's a twice of x square. It's a twice of x square is my 4 times x square. Similarly, you can find the second part. How you can write this number is del upon del x of fy. So again, you have to write this is fy, this is my x. Fy is dependent on the u, fy is dependent on the x, fy is dependent on the v. And now you have to complete this matrix. What is the value of the u with respect to the x? 2xy, x with respect to x 1, v with respect to x 3, and this is the same expression that we have obtained previously. Fine. Now you can multiply them. 2xy into this expression, 1 into 2xy, and so on. Now since del square f upon del u into del v is same as of del v into del u, so I can combine this number is a 4xy and it is a 3x square. So 4xy plus 3x square is my common, and the rest of the expression is the right. Okay, look at this one. This is a very important question. Let w is a function which are dependent on the u and v, and u and v are again dependent on the x and y. That means we have to apply the chain rule. Your target is to find the wx. So firstly, your target is to find the partial derivative of w with respect to x, w with respect to y. Now I can complete the chain rule. This is w dependent on the x, w is dependent on the u, w is dependent on the v, u is dependent on the x, v is dependent on the x. What is the value of the u with respect to x? 1. V with respect to x derivative is my 1. What is the meaning of this is del u by del x. This is my 1. What is the u with respect, what is the w with respect to u? That is only f dash of u, because this is the function which is dependent on the v only, and this is my g dash of v. Now what is the answer of this? That is a multiply f dash of u plus g dash of v. Similarly, for the second case, is a w, is a y, w is dependent on the u, it is v, and this expression. So can you write this u with respect to y? Iota, this is minus iota. This is f dash of u, this is g dash of v. You have to draw this diagram in the examination as well. Fine. So what is the answer of this is iota f dash of u minus iota g dash of v. Fine. Make sure, student, you have to draw this diagram in the examination as well. Now your target, the next one is your target is to find this expression. Again, I can write this number is fine. So again, I can apply the chain rule. For example, in the first case, I have to write wx. Fine. So I can write the chain rule. Say wx of the x. Wx, this is my expression. Again, it is dependent on the u. It is dependent on the v. Fine. Now you can complete this table. U with respect to x 1, v with respect to x 1, wx, this is my wx. Can you find the partial derivative of this with respect to u? So this is my f double dash of u, and this number is, because it's a v is a 0, wx with respect to v is of this expression. Now can you find this number? So that expression will be my, you can multiply them. It is f double dash of u plus g double dash of v. Fine. Now similarly for this category, I have to find del of del y. So I can write this is wy, this is y. Wy is dependent on the u, wy is dependent on the v, and so on. So this value is again iota, this is minus iota. Can you find this value wy? Can you differentiate this with respect to u? So it's a iota f double dash of u, This is minus iota g double dash of v. Now can you multiply them? Is a iota square is a minus 1 f double dash of u, minus minus plus iota square, which is again minus g double dash of v. Now your required target is to find the addition. If you add them, clearly say the answer will be 0. And this is the way you can solve this in a very simple manner. Don't forget to like and comment on this video, and you can share this video with your other students as well. Now you can see w is dependent on the x and y. Sorry, it should be the u. It should be the v because it's f of uv. Fine. And u is dependent on the x and y. So that's again the chain rule is applicable. So your target is to find the wxx. So firstly, your target is to find this. Remember student, this is my u and this is my v. Fine. Now how you can find this? Again, for the chain rule, as I recommended you, you can watch this lecture. Now w with how you can write this number is a w upon wx. So x is my dependent. Now look at that, w is dependent on the u, w is dependent on the v, and here. Now can you complete this? U with respect to x. What is the derivative of u with respect to x? Only x. Fine. V with respect to x, y. Can you find the derivative of u, w with respect to u? So that is my del f upon del u, and this is my del f upon del v. Can you find this expression? So this number will be my, if you multiply them, it is my x del f upon del u plus y del f upon del v. Similarly for this y, I can say w is dependent on the u, this is on the v, and so this expression is same, del u by del x, del f by del v. What is the value of the u with respect to y? If you differentiate this with respect to y, its answer is minus y, this is x. Now if I multiply them, minus y into del f upon del u plus x del f upon del v. Fine. Again, you have to draw this diagram in the examination. Now your target is to find the wxx. That means your target is to find this expression. So for that case, again we can apply the chain rule. So you can see I have to draw the diagram of wx with respect to x. This is with respect to x. Wx, okay, I can write in between them. So that will be, okay, I can write here. That will be wx and it is my x. Now look at the expression of the wx. It is dependent on the x, it is dependent on the y, it is dependent on the u, it is dependent on the v. So I can write it is dependent on the x, it is dependent on the y, it is dependent on the u, it is dependent on the v. Fine. Now you can complete this chain rule. Now firstly I can complete this value, v with respect to x. V with respect to x is my y, x with respect to x 1, because x and y are my independent, so y with respect to x is my 0, u with respect to x is my x. Now you can see, firstly can you find this wx with respect to v? Fine. Now I can write here wx, can you differentiate this with respect to v? So x is my x, f of it will be my f of v into u. Fine. Y will be my y, and f of vv is my this value. Fine. So this is the value of this expression, x f of v into u plus y f of v into v. Now look at this one, wx with respect to x. So this is, there is independent of the x, that's a 0. The derivative of this is my f of u. Wx with respect to y, this is my f of v, and wx with respect to u, so x f of u into u plus y is my independent of u, and this expression is u into v. Fine student. Make sure student this fv you have to differentiate this value with respect to u. So y is my outside, so this value will be my f of u with respect to v. Now once you know this expression, can you write the wxx y into this, because it's a 0, so this number will be my 0. So y into x times, this is a y into x times 1 into f of u, 1 into f of u, and x into x f u u and so on. Now if you open this bracket, it is the x square f of u u plus xy of f uv plus xy f of uu and so on. Now clearly say f of uu and f of vu are same, so you can say, oh, where is the, this expression is f of vu and this expression of fuv, so they are combined. This is the expression of f of uv, sorry, this is my y into f, and this is x into vu, this is a vu. Fine. So if you combine them, it is a yx and it is xy, so that's the twice of xy. Fine. Similarly, you can find the value of y. How you can find that? Again, I can start with the wy, fine, and with respect to y, because this is the expression of wy. Look at the wy, they are dependent on my u, they are dependent on my x, they are dependent on my y, they are dependent on the v, and now you can see these expressions. Can you substitute the value of u with respect to y? U with respect to y minus y, x and y are independent, so it's a 0. Y with respect to y 1, v with respect to y x. Now can you differentiate this function wy with respect to u? So it is my minus y f u into u, and this value will be plus x f of u into v. Can you differentiate this function with respect to x? This is only f of v. Can you differentiate this with respect to y? It is minus f of u. You can differentiate this function with respect to v. So minus y f v into u plus x f of v into v. Now you can multiply them. It's a minus y into minus y plus 0 into something is 0. 1 into minus of fu is my minus fu, and x into minus y of this value. Again, I can use the expression f uv is equal to f of vu. So this expression and this expression minus xy, that's the twice of xy. Now finally your answer is needed to, you can add them. This is the value of this. If you add them, this value will be cancelled out again because of this expression. F of u will be cancelled out, and then you will get this expression. Clearly say if I take x square as my common, it is my f of uu plus f of vv plus y square is common, f of uu plus f of vv. Again I can take fuu plus fvv common, and this expression will be, and the value of this expression is given to you as my g. Fine. So always remember, you can apply the chain rule in a very simple manner. Don't forget to like and comment on this video. Again you can see u is the function of x and y, and x is a function of r and theta. So that means you can apply the chain rule. My target is to apply the urr. So firstly, your target is to find the del u by del r. How you can apply? You can start with the u and r. U is dependent on the x, u is dependent on the y, x is dependent on the r, y is dependent on the r. What is the u with respect to x? It is not given, so it is a f of x. U with respect to y is f of y. X with respect to r cos theta, y with respect to r sin theta. So can you find the value of the u of r? UR is basically del U by del R. So that is cos theta into Fx sin theta into Fy. Fine. Now your target is to find the del square URR, that means of UR. Again, I can apply the chain rule. Fine. So I can start with the UR. Okay, I can start with the middle UR and R. Now look at the expression of the UR. It is dependent on the one is at theta, second is my X, second is my third is my Y. Fine. Now, can you differentiate this UR with respect to theta? So this expression will be minus sin theta into Fx plus cos theta into Fy. Can you differentiate UR with respect to X? So it is my, this expression is cos theta into F of XX plus sin theta into F of X into Y. Can you differentiate this UR with respect to Y? So this expression is cos theta into Fyx plus sin theta into F of Y. And you can complete this diagram. What is that theta with respect to X, with respect to R? Because theta and R are my independent, so there is a 0. X with respect to R is a cos theta. Y with respect to R is my sin theta. Now can you write this expression? 0 into something is 0. This is cos into this, that's my cos square Fxx, cos into sin Fxy, and so on. Again, I can use the Fxy is my F of Yx, then you can get the right answer. And that is the required proof. Okay, now in this case, there is no chain rule applicable because the function f is dependent on the x and y, but x and y are not dependent on further. So your target is to find the value of fx directly. Can you find the value of fx? So it is 1 over x square plus y square into 2x. Similarly, what is the value of the fy? It's a 2y over, what is the value of the fy? It is 2y over x square plus y square. Now your target is to find the value of the x. You can apply the product rule or you can apply the division rule. So that will be x square plus y square. With respect to x, it's a 2 minus of 2x. If you open this bracket, you will get the expression as 2y square minus 2x square. Similarly, you can find the value of fy and you can find the fyy. Now if you add them, clearly say if you add them, the LCM is same. 2y square cancel, 2x square cancel, the answer is my 0. Look at this another one. Again, that's a very simple. Again, there is no chain rule applicable. You can find the fx. What is the derivative of the tan inverse y over x square into derivative of with respect to x minus y over x square. I can take the LCM, x square will be cancelled out, is x square plus y square minus of y. Fine. Similarly, you can differentiate with respect to y. How you can find the f of xx? I can use the product rule. It is x square plus y square of whole square. Now it is x square plus y square with respect to x. So that will be my 0 minus y of 2x. So that is my 2xy minus, and it's minus minus plus. So 2xy over this quantity. Similarly, you can find the value of the fyy, and that you can see if you add them, you will get the required proof. Again, the chain rule is not applicable. So firstly, you can find the value of the fx. You can find the value of ft. What is the value of the fx? 3 times square. What is the value of the t? Is 3 times of a x plus at square. Fine. And then you can differentiate twice. Can you find the value of the x? So it will be 6x plus 80. F of twice up is a 6a x plus a into t into a, that's a square. Fine. Now you can see clearly say if I this result hold. Now these questions are exercise for you. You can try to solve this, and first case you have to verify this satisfied, and in this case you can see this is the chain rule. Why? Because u is the function of the x and y are also dependent. So you can find the value of the urr by the chain rule. You can find the value of the u, theta and theta with the chain rule. And then you can substitute the value on the right hand side, check whether the left hand side exists or not. You can try to solve these problems and let me know in the comment box, are you get the same answer or not. We will see the next lecture on the direction derivative. Till then, you can like, share and comment on this video. You can share this video with your other students in your institutes. Best of luck students, and don't forget to subscribe my YouTube channel. Happy learning always. Best wishes.